Okay, so we do not have any participants yet.
Or maybe our topic is not so interesting, but
So,
I don't know if the challenge is because
hello everyone. So here we are with another session of LRVS 2023. Let's get ready to welcome Mika Perttula, CEO of Fluid Intelligence, to tell us more about going flat with Lube emission, the story of a waste treatment facility. And today is going to be a recorded session, and after Mika will be available to have some questions as well. So having said that, let's play the presentation.
hello and welcome to Lubrication and Reliability Virtual Summit 2023 EMEA edition and on track 3. My name is Mika Perttula. I'm the CEO and co-founder of Fluid Intelligence and an active participant of LRVS community, addressing topics like sustainability, digitalization, operational performance, and economical aspects. In today's session, going flat with Lube emissions, it's a story of a waste treatment facility. It's a story of transformation, how we were able to help our customer to move from time-based model to a proactive strategy. It's a story of digitalization and real-time monitoring, how our customer was able to benefit of digital tools and means in their maintenance operations. And it's also a story of environmental, operational, and economical gains that we were able to achieve with our customer during the past 4 years. I will first cover current state back in 2019, where we started with our customer, then the performance over the course of next 4 years, and proactive actions we took with them to maintain the performance of the fluids and machines in a target level. Then I will briefly cover the benefits that we've gained so far, and then address also the CO2 emission analysis and reporting, along with brief future outlook of how the world looks for them after these 4 years, and then a brief summary. Well, let's start from the beginning. Lassi and Tikanoja, they are one of the leading Nordic circular economies companies, and they serve a range of industries, from facility management to environmental services like residential waste collection and industrial services like dealing with hazardous waste and so on. They have a revenue of 800 million and they employ over 8,000 people currently. We started to work with the Kerava waste treatment facility that is close to Finland's capital Helsinki. And in this facility, they have 6 heavy crushers and baling machines, and they use hydraulic oil that is in a constant high stress. The production is 24/7, so each and every machine is in critical process. Before 2019, they applied a calendar-based maintenance model, and they had 6 to 12 months oil lab sampling interval. And they also applied line and offline filtration to some of their machines. So let's see these machines on a bit more closer. So they have two big crushers, one for wood waste, one for construction waste. The wood waste crusher has oil volume of 500 liters, that used to be changed 3 tons a year. So coming all together to 1,500 liters per year. All the other machines, oil were changed once in a year. So the total volume for oil, 4,200 liters, and they were generating 12.6 tons of emissions each year. And continuing this way from 2019 to these days would have generated over 50 tons of CO2. So the actions what we took initially when we started to work with them, we received historical lab sample data and the briefing of a maintenance practices prior to our cooperation. We took the baseline lab samples as well, and then we agreed with the customer that we will install fluid trend real-time oil performance monitoring with 2 of the biggest machines, and we will continue 6-month oil sampling interval with all of the machines. So as a starting point, when we see the performance, our service fluid eye calculated a health index for each and every machine based on the lab data, the scale of 0 to 100, containing a weighted index of wear metals, contaminants, cleanliness, and oil condition. So we were able to see that the starting point was pretty good. They had changed the oil in April-May time 2019. So the starting point was fairly good for us. Let's see how the performance developed over the course of these next 4 years. So we can see that as a whole fleet, 6 machines, the performance has been fairly steady. There hasn't been a big deviation in most of the machines, except this one construction waste crusher that was in the most heavy working conditions. But all the other machines have been performing fairly well, and we haven't seen too many alerts from real-time monitoring either. So let's see what actions we took with the customer to optimize the performance of the fluids and also extend the life cycle of the fluids. So most of the activities were targeted to this construction waste crusher. As we first saw on 2020, first hints of potential anomalies in the performance. And if we take a closer look on that, we can basically see that the customer was changing the oils earlier in the years based on the calendar. And then when we started to work together in spring 2019, the performance for the fluid was very good. But then we got some indications from real-time monitoring that there are impurities that lab sample then also verified, and based on that information, the customer applied new offline filtration unit in this machine. Going forward, we were able to record the development of the cleanliness, and the filtration unit is working, and we are getting less and less impurities in the system. But then next, because first indications from real-time monitoring, that there are some challenges with temperature, ambient temperature, and also the oil temperature. And when we were getting closer to the summer 2021, that was really hot summer, that basically then escalated the situation, and we were able to see that the ambient and oil temperature is really too hot compared to the target levels. And based on this, the customer took the next actions. So they applied oil cooler in this machine, and then based on this activity, we can see that the oil has been performing fairly steadily since then, and also the quality of the performance of the oil has been improving steadily until these days. Then most of the other activities were focused on this other hydraulic press that had a really small volume of 200 liters of oil. And in 2021, the customer wanted to change the oil and make a test that to see what kind of impact an oil change have for oil and machine performance. And as we can see from this development, there hasn't been that big changes for the oil and machines performance. So after this trial and test, the customer continued production with this machine, and no further oil changes hasn't been applied so far. Now, this summer, there were some minor indications of performance with this hydraulic press, and then basically customer improved air filtration in this unit, and now we're in a situation basically where all the machines are performing well, and we are not seeing any adverse development for this machine fleet. But as a whole, we can see that 4 years, 6 machines in a very harsh environment, with a lot of heat, a lot of impurities, 24/7 production. The fleet performance has been really good, and with few detailed actions, we've been able to keep the fluids and machines performance there where we want to keep those. So going to benefits, as my colleague and our founder, the account manager for LFD customer, puts it well, but small actions lead to major gains. And as we saw in a previous slide, 6 machines, 4 years, earlier there were a lot of plant maintenance breaks, a lot of oil changes, and so on. With these timely actions, we've been able to run this fleet with no unplanned downtimes and machine failures. Of course, constant real-time visibility, holistic visibility for this has helped our customers to go from time-based model to proactive maintenance strategy. We also reduced maintenance costs quite considerably because there hasn't been that much planned activities. There hasn't been that much need for spare parts, oils, and other oil-related costs. So total cost reduction versus old model has been at least 50%, if not more. When we see it from environmental perspective, the gains have been even more significant. So in the old model before 2019, if the customer would have continued that way the next 4 years, they would have consumed 16,800 liters of oil and generating over 50 tons of CO2 emissions. Now going with the new way, oil volume is only in 3,400 liters and in plus 10 tons of CO2 emissions. And what it means in practice is that earlier they would have done an oil change 32 times in these 4 years of time, but now they just did it 5 times. Now the total emission savings versus old model are over 40 tons of CO2. That is over 80% less compared to previous performance. So quite a notable savings from environmental, economical, and operational perspectives. Now let's turn our eyes briefly to emission analysis. So today, emission analysis and reporting may seem to be quite entangled. There are several different directives and frameworks from different continents, like EU's Corporate Sustainability Reporting Directive that will be coming in force next year for the largest companies. There are several different reporting standards and models, like Global Reporting Initiative and World Resources Institute's Greenhouse Gas Protocol. And not to mention also the ISO and other specific codes, like ISO 14040, that is a standard for life cycle assessment and analysis. And of course, the baseline numbers that you use in your analysis, that is maybe the biggest question, depending on the source of the lubricant oil, depending on the base oil. Is it the mineral oil, full synthetic oil, a bio-based oil, or how much you've used antioxidants, for example, in the oil? Makes a lot of variation for the CO2 emissions. But what you many times see is that in many industrial presentations, people refer to an average number of 3.4 kilograms of CO2 per 1 liter of lubrication oil when disposed basically with burning. So this is the framework where we need to operate. Of course, how do we create the CO2 analysis and report? That needs to be also fairly holistic and cover basically the whole life cycle of that specific product or service that are we analyzing. So many times we use life cycle assessment models where we first define the product manufacturing and delivery of the product. So in lubricant oil first, when lubricant oils are in question, so the raw material exploration, refining and production of the lubricant, packaging and logistics, and of that we usually name from cradle to gate. So once it's gate of your end customer's factory, and then going forward, using the product itself, and then the end of life of the product. Will it be burned, or are you delivering that to a refinery, where a big part of waste oil can be refined as a new base oil? So that whole life cycle is then basically covering it from cradle to grave. And depending with whose eyes you're seeing this life cycle assessment, then it depends also that how do you report that in in your annual ESG report. And of course, when we see production of lubricant oil, then the scope 1, that is the direct emissions that you are creating, that is naturally the emissions that oil companies, lubrication manufacturers, and chemical companies report in their in annual reports. But when you see the whole end-to-end life cycle, then basically scope 3, that also covers use of the lubricant, the end of the lubricant, then that's many times then the industrial companies, the process industry companies who use the lubricant, because they are not using lubricant as a byproduct for creating something more value-added or larger product or services. So that is more like a scope 3 emission then that they are reporting, basically end-to-end from upstream to use and downstream of your value chain. Then seeing how we did the life cycle assessment and CO2 analysis in this LRT case. Here is an example of one of the crushers, wood waste crusher. So we basically used a fairly conservative baseline number, 3 kilograms per liter, and as earlier there wasn't a capability to deliver this oil to the re-refinery. Earlier, this waste oil was disposed as energy. So 3 kilograms per liter, and here we can see that if the customer would have continued this, in this case 3 times a year oil changes, they would have changed the oil 12 times until this summer. But now once we started to work together, we've been able to keep the oil change in this one oil change. And actually in this case, it's been even more than 80% how much we have been able to reduce the CO emissions for our customer with our fluid eye model. So quite a big environmental benefit for this customer. Now, how the future looks like to LRT, we've seen that the performance has been really good. We've been able to extend the life cycle of the oil for the whole fleet already quite a bit. We are not anticipating new oil changes or scheduled maintenance breaks that would be due to lubrication or hydraulic oils. We are continuing real-time monitoring, regular lab-based analysis, and also oil reconditioning activities with our customers to keep the performance of the oil and machines where it needs to be. And this way, our customers' annual CO2 emission savings are actually continuing to grow steadily, because the same lubrication oil that we changed 2019, we are running further and further, then annual CO2 emissions are then reducing respectively. So as a summary, I would say that people are everything. People are the ones who make things happen. And as in this case, our customer wanted to go from time-based model to proactive model. It was their team, their people, together with our experts, who were able to make this strategic change and go with proactive, data-driven model. And then, of course, real-time data and holistic visibility for the whole fleet. that has then helped these teams to perform better, move to proactive maintenance strategy, and also take the timely actions when needed. And when there's need to take the action, you need to take those early, because once you take the actions early, those are much more cost-effective or cost-efficient and effective. And in most of the cases, we can take so tiny actions that we don't need to have a downtime to implement those, but we are taking those while production, and that makes them even more efficient. So this way we can minimize CO2 emissions and reduce costs without compromising reliability. Thank you very much for your attention. And if you want to continue this dialogue, we'll have a Q&A session after this presentation, and please do not hesitate to contact me. Thank you.
Right. Thank you very much, Mika, for your presentation. And yes, indeed, we have a couple of questions. One is a comment from Islam Savory. Great presentation. And the other one is coming from Bruno Paisha. Did the online filters operate on a 24/7 duty? And if you consider to use these filters was more effective than online?
Okay, so if I understood correctly, so you talk about like inline filters that are basically coming with the machine initially. So yes, I think that we saw. So in this case, that we really needed to add better filtration over there for these few machines, and because otherwise we would have ended in really much shorter oil lifetime, and as far as I understand, the offline filters, those have been operating 24/7, so always when the production has been there, and yeah, that's basically briefly how it's implemented there.
Just Bruno, I unmuted, so you should be able to talk if you want. Was this is all clear? Well, I guess so. We are approaching now the end of the session, and so it will be in 2 minutes. If there are any other questions. No? Okay. So let's thanks Mika for your presentation. And thank you very much for the attendees to learn something new.
Yeah.
All right.
Thanks for attending.
We'll be ending the seminar now. Yes, thanks for attending, and bye.